Good evening once again. This evening we are going to continue with the session 4 of our unit 5, which is the applications of normal distributions. Applications of normal distributions. Section objectives. By the end of the session, you should be able to compute probabilities from the normal distribution and the normal curve. You should be able to compute percentages from the normal distribution and the normal curve. And finally, you should be able to determine performance levels based on the normal distribution and the normal curve. So the application has been categorized into three. The first part will concentrate on probabilities, the chance of certain things happening. And here we are going to consider the chance of students scoring either more or less than some specific values, or the chance that some students scores will fall between certain values. And the next one will be the percentage of students who are likely to score either above or below, or still in between. And finally, you'll be looking at the exact number of students. We'll be looking at the performance levels. And here we will still be computing using the normal distribution and the normal distribution curve. Okay, let's start with the first application. Finding probabilities. Finding probabilities. And we all understand probability to be the chance of something happening. In mathematics, we did probability. The first example is the distribution of scores for a class of students in a statistics examination is normal with a mean of 60. So we have our mean to be 60 and a variance of 64. And now put in a symbolic form. X is normally distributed over n. We have our mean to be 60 and we have our variance to be 64. We have our mean to be 60 and our variance to be 64. A student is selected at random from the class. So a student is selected at random from the class. The question is, what is the probability that the student selected at random, or the student selected, obtains a score above 68? So we are assuming that a student has been selected, but we don't know the student who was selected, and we are assuming that the student score above 68. We want to know the chance of selecting a student who scored above 68. So here, the steps that you follow in deriving the probability of a student scoring above 68 has been outlined, and we expect you to follow the steps. But I don't expect you to write the steps when you have been given a question. You have to only follow the steps in helping to understand how you go about it. So after, don't memorize the steps, don't use them in answering the question. Don't write the step down as you are answering a question. Okay, what you have to do first is write the problem in probability form. Write the problem as have been stated in the question in probability form. In writing the statement in probability form, this is how we go about it. You write the P here is probability, and into bracket we have X greater than 68. The question was the probability that a student selected obtains a score above 68. So we want to know the chance of selecting somebody, any of the students who scored above 68. So X is greater than 68. X is greater than 68. The student we select, or the student who was selected, scored above 68, is likely to score above 68. That is our prediction. So this is how we write the problem in probability form. The second step is transform the original probability form to a z-score form. We know how to compute z-scores. We are saying that you have to convert the original probability form to z-score form. So we are going to convert the question to z-score form. We are going to standardize the question. since we are going to use the standardized normal distribution curve, which has a constant mean of 0 and a standard deviation of, the area under the curve of 1. Now, the formula for z-score is z equals x minus mean over standard deviation. X minus mean over standard deviation. This is the formula for the z-score. We want to convert the problem from probability form to z-score form to standardized form. So to converting to standardized form to z-score form, we need to follow the z-score formula. So we will quote the probability symbol the probability in a probability form again, which is the mean probability outside p outside into brackets, the chance of picking a student who had a score, the x and obtained score which is above 68. So when we substitute this into the formula, it's going to be, we have our x here, that is the score which we are saying the person's score is likely to be above or more than. That is 68, the score in the question, 68. And our mean is 60 in the question. Our mean is 60. Now we don't have standard deviation in the question. So what we have to do is we find the root of the variance given in the question. And by finding the root of the variance given in the question, you'll be able to come back to the standard deviation. The root of the variance will give us the standard deviation. So 64, the root of 64 will be 8. The root of 64 will be 8. So after this, now we know the z-score formula. We have substituted the values into the z-score formula. So we need to reduce the terms. We need to compute the numerator and after divide by the denominator. So the 68 minus 60 will give us 8. 68 minus 60 will give us 8, and we have our denominator to be 8. Let's move to the next slide. Okay, here the 8 over 8 will also give us what? 1. 8 over 8 will give us 1. 8 over 8 will give us 1. And therefore, in reducing the terms further, the p into bracket z is greater than, it becomes z is greater than 1. The 1 is our answer. So the next thing is you sketch the area for the normal curve. And we know the area for the normal curve is z-score is greater than 1. Z-score is greater than 1. So here you draw your standardized normal curve. So we have our 0 here because it's standardized normal curve. Then you number accordingly. You can number on the left side too, but now our focus is a score above 1. So that means we need to shade the values above 1 because that is where the score is likely to fall. To fall. Remember, this is probability, the chance of an event happening. And here we are saying that what is the chance of picking somebody who scored above 68. So converting to z-score, we got 1. And z-score on the standardized normal curve, we have traced our 1 here. And we are saying that the chance of the student scoring above 68, which has been converted with the respective mean and standard deviation to give us 1, shows that the score will fall above the 1. So you shade values above the 1. So if it was below 1, below 68, then we would have shaded the part below the 1. I mean from the 1 towards the left direction. But since it is above 1, we are shading the top of the 1 because the value is likely to fall there. The C step is, remember that the area beyond 0 to the right is half of the area of the normal curve, and this is 0.5000 is 0.5, but because we are dealing with 5 decimal places, so I mean the value you pick from the standardized normal curve table is in 5 decimal places. So instead of writing 0.5, we write it as 0.5000, and the area between the 0 and the 1, 0 here and the 1, is 0.3413. Therefore, to get the area shaded will be, you deduct the 0.500 from the 0.3413 from the 0.500. All I'm saying simply means that since the concentration is on only one part of the curve, above, which we all know it is one-tailed, we are saying that means the focus is going to be on the right half of the curve, but not the entire curve of the entire area of the curve. And we learned that the total area under the curve is 1.0. And remember I said the normal distribution curve is symmetrical, meaning when we divide it into 2, we will get halves. So each side will be 0.5, 0.5. And we are saying that since the value fall at the other half, we need to first set for the z-score from value from the table for 1. Since after converting the 68, we got 1. So we have to search for 1, the corresponding value, z-score value on the table for 1. Then after deduct that from the half of the curve, which we know to be 0.5. So by deducting that from half of the curve, which is 0.5, we'll be able to get the predicted value, which is in the seventh step. Write the final answer. So 0.500 minus 0.3413 will give us the final answer. Okay, and we got the 0.3413 from the table. Since our answer is 1 here, the conversion gave us 1. You go to the table, and I've already taught you how to search for 1 on the table. Since it's in only one decimal place, you search below the heading 0.00, and 0.00 to 1 will give us 0.3413. This table is at the back, is the last page of your book, so kindly refer to the last page of the book. We have this table there. Trace whatever number you get from there. I mean, after converting to z-score, trace from there and use the value you get from the table in doing your calculation. Okay, so this is the value here, since it was 0.3413. Now let's go to the second example. The distribution of scores for a class of students in a statistics examination is normal with a mean of 60 and a variance of 64. The question looks alike. We have just taken the first part and I've extended it. So we are using the same mean and the same variance. So what is new here is a student is selected at random from the class. And the follow-up question is, what is the probability that the student selected obtains a score greater than 76? So you follow the same procedure. Now, you first have to write down the problem in probability form. We are talking about a score greater than 76. So the score x should be greater than 76. So P into bracket X greater than 76. The second step is transform the original probability form to z-score form, remembering that the z-score formula is, so you don't have to write this, just go straight to the calculation. So you have to quote the z-score formula, which is, or you may decide not to even quote, it's not necessary, which is x minus mean over standard deviation. And the next step, what is our x? Which x are we considering in the question? It's 76. We want a number which is greater. We are predicting that the student we selected is likely to score more than or greater than 76. So we are using the 76 in the question. So it will be 76 minus, what is our mean? The mean in the question is 60 minus 60. And like I said earlier, in some cases, you'll not be given the standard deviation, but you'll be given the variance. And we know the variance and the standard deviation move together. So when you are given one, you have to, based on that, to determine the other. And here, since we have 68 as our variance, all we have to do is find the square root of 68. Or sorry, 64. Find the square root of 64. And the square root of 64 will be what? 8. So the 8 become our standard deviation. We don't need the variance in the formula, a standard deviation. So we need to convert the variance to standard deviation first. So now the formula become 76 minus 60 over 8. 76 minus 60 over 8, which will give us, the 76 minus 60 will be 16, and we have the denominator to be 8. So in reducing the terms further, in moving another step, subtracting 60 from 76 will give us 16, and it's over 8. So 16 over 8. What is 16 over 8? We are going to get 2. 16 over 8 will be 2. So the next thing is you draw the normal distribution curve, and it should be the standardized normal distribution curve. Since we are going to convert to standardized normal curve, we need to draw a standardized normal distribution curve. We are going to standardize the value because we are dealing with the z-scores. So as you can see here, we have our mean to be 0. So you can continue with the other numbers at either side. But now, because I'm considering a score greater than, which is one-tailed, which is taking one stand, one-tailed, directional. So my focus will be on the right side because it's greater than. And after computing, I got 2. So this means I have to shade the values after the 2. Because after converting the 76 to the z-score, the value I got is 2. The value I got is 2. And so this means I have to stand on the 2 and shade the spaces after the 2. The spaces after the 2. The C step is, you remember I said the area under the curve is 1. The area under the curve is 1. And since I've taken stand, I'm moving towards the right direction, greater than. So I'm going to consider only one half of the curve. And if the total curve is 1, if the total curve is 1.0, then one half of the curve will be 0.5. And the other side will also be 0.5. 0.5. So if I need a score which is greater than 76, then I have to, after converting the 76 to z-score, which is 2, I have to first search for 2 on the standardized normal distribution table. So I have to search for 2. When you come to the standardized normal distribution table, we have 2 here. And remember I said anytime you are searching for a value which is in 2 decimal places or 1 decimal place, for the 1 decimal place, you can get your score immediately under the title point 0.00. So for 2, you can trace 2 here to get 0.4772. That is the one which corresponds to the 2. So you pick that value and now deduct that value from back. You deduct that value which you go from the table from half of the area of the curve, which is 0.500. Okay, 0.500. It can be 0.5, but because we are dealing with the value we got from the table is in 4 decimal places, that's why we've added 3 zeros to it. Okay, so if you just deduct it from 0.5, you get the same value. But for consistency's sake, you have to add the 3 zeros. Okay, so by deducting, now the final answer becomes 0.0228. 0.0228. So this is the probability of picking a student who scored greater than 76. This is the answer, 0.0228. Okay, the third example is the distribution for a statistics examination is normal with a mean of 60 and a variance of 64. A mean of 60 and a variance of 64. Still the same values. But here the only difference we have here is that a student is selected at random from the class. And the follow-up question brings the difference. What is the probability that a student selected obtains a score between 52 and 76? Between 52 and 76. Between 52 and 76. So, since we are considering the scores between 52 and 76, you can see that we are now on the two-tailed direction. We are not considering any specific stand, whether we are going the left or the right way. So, after quoting your probability, putting your problem into a probability form, as we have here, P into bracket 52 is less than the value X, and the value is also less than 76, because we know the value the value we are predicting should fall between 52 and 76. So we are going to work the probability in 2 parts. So we will use the z-score formula. The same z-score formula will be repeated for both parts, for the below and the above. So the first part we have at the left side and the second part at the right side, which is x minus mean over standard deviation. X minus the mean over standard deviation. So the first part, which is 52, this 52, the 52 here minus the mean and over the standard deviation. The other part, the upper part, is the 76 minus 60, which is our mean over the standard deviation. 76 minus the mean over standard deviation. And remember how we got the standard deviation. Remember I said since we have the variance, we have to just find the square root of the variance, which will be 8. So you work in isolation. 52 minus 60 will be negative 8, as we have here, negative 8, and is over 8. Then the other part will be 76, which is 76 minus 60 over 8 will be 16 over 8. So that one too is here. And now the final probability will be negative 1. So converting the 52 will give us negative 1. Negative 1. And the 76 will give us 2. That is in the z-score form, in the standardized form. And so here what we have to do is to search for the z-score value for negative 1 on the standardized normal distribution table, the summarized table. And we have to also search for 2 on the table. But in our case, we don't have negative 1 on the table, so you will use 1. You will search for 1. You will search for 1 on the table. And on the table, the value for 1 will be what? 0.3413. And the value for 2 will be 0.4772. 0.4772. Sorry, there's a mistake here. It's supposed to be 2. And this will give us 0.8185. So this time we're not going to subtract from the other half, the 0.0500, but rather since it's between, anytime it's between, take note, we add the values we get from the table. So let's take note of this. Okay, let's go to the second application. The second application, finding percentages. Finding percentages. We are through it, finding the probabilities. Now we are going to find percentages using the normal distribution and the normal distribution curve. Example, given that the distribution of the performance of students in an examination is normal, with mean 16 and standard deviation of 2. What percentage of the students obtained scores less than 12? Obtained scores less than 12. So this time we are lucky, we have a direct standard deviation. We are not going to square root to come out with the standard deviation. So in some instances, you'll be given the variance, so you have to compute to get the standard deviation. And some instances too, you have to use the standard deviation given in the question. The first step is, remember I said you're not going to write the steps as I have written on the slide. This is to just guide you. The steps I've written are to just help you to be able to write or follow the steps to come out with the correct answer. So don't write this for me. Don't write this when you are given a question. Just go straight to the solution. So the first thing you have to do is you have to convert your problem to probability form. You have to convert your problem to probability form. I mean the entire question to a probability form. And the entire question is looking for the percentage of students who are likely to score less than 12. So now we will use X to represent the percentage of students who are likely to score, I mean the scores of the students. And we are talking about a performance which is less than 12. Their performance which is less than 12. So you draw the less than sign or symbol, then you follow it with the number in the question, with the score in the question, which is 12. So P into brackets, we have X less than 12. The next step is you have to now write the z-score formula. You write the z-score formula, which is X minus mean over standard deviation. So you need to now standardize the probability. I mean convert the probabilities to standard to z-scores. Bringing the probability to z-scores or converting it to z-score, in the question we have 12 as the value we want to know the percentage of students whose scores are less than. And so you write the 12 first as your X minus the mean in the question, which is 16 over the standard deviation. So 12 minus 16 over 2 will give us negative 4 over 2. So please let's take notes. Whether it is greater than or less than, you will still use the same approach. The value in the question will still come before the mean. Let's take notes. Remember the previous examples I considered more than, greater than, they were all one-tailed, just like this one. But with that one, I was moving towards the right direction, greater than. But this time around, you can see I'm moving towards the left direction. So you don't have to be confused. We are using the same formula. The value in question will come before the mean in the question. Then you divide both, I mean subtracting the mean from the value in the question. The next thing is you divide your answer by 2. So here, reducing the term further, 12 minus 16 will give us negative 4. 12 minus 16 will give us negative 4. So negative 4 divided by 2. Negative 4 divided by 2 will give us what? -2, -2. So the next thing is you write the answer, which is z is less than -2. Z is less than -2. Then after, you have to draw the curve. If you fail to draw the curve, you lose some marks. So you draw the curve. And this time around, since we are dealing with a score less than, so we think of moving towards the left direction. Remember, the scores, the values under the curve decrease moving towards the left direction, and they increase moving above the mean, which is 0 for standardized normal curve. So after converting to z-score, we got -2, and we are saying that the score is less than 12. The 12 which has been converted to 2, z-score of 2, -2. Now we have to shade the values which are which are less than -2, which moves below the -2. So on the curve, we need to shade the values which move below the -2, because you know with negatives, the greater the value, the lesser it is. Okay. And since we are still using one-tailed, it's less than, just like the greater than, we have to consider only one side of the curve. And remember, I said the entire curve has a total area of 1.0. So if you are considering the 1/2, which we know the curve is symmetrical, that 1/2 is 0.5. So what you have to do is, after tracing for the 2 from the table, which you will get 0.472, you have to deduct it from the total for the half you are dealing with. It's less than, so we are dealing with the other half, which is 0.500. You have to deduct the value from the table. The 2, you will get 0.4772 from the table. So you deduct from this and you get 0.0228. But this time around, because we are asking you to find the percentage of students who obtain scores, which are less than 12. Remember, on the first in the first session, I said when I'm teaching the applications, we will be doing some conversions to percentages. We are going to convert to percentage. So after getting the value from the table, deducting from the half of the curve, anytime the question asks for the percentage of students who score below, now you move further to multiply your answer by 100. So the answer we got here, which is 0.0228 times 100, will be 2.28%. 2.28%. Let's take note of that. Now the final aspect of this session, the third application, finding the number of students. Finding the number of students, the actual number of students. Anytime the question asks you to find the actual number of students, you move a bit further, just like we did for the finding of the percentages. Remember, after converting to the normal probability, the z-score, after getting the probability value, just like with the first application, we moved further to multiply by 100. But this time we're not going to multiply by 100. We want to find the actual number of people who are likely to either score above or below or between, as I've been explaining. Let's start with the example here. Given that the distribution of the performance of 400 students in an examination is normal, with mean 16 and standard deviation of 2, about how many students obtain scores less than 12. So you can see the difference between this and the previous one is that this one is asking for the actual number of students who scored less than. So we are looking for the actual number of students, not the percentage. But the previous application was asking for the percentage of students who are likely to score less than 12. And the difference between this same application and the first application is that this one is asking for the exact number of students who scored less than 12. So it could have been the actual number of students who scored more than, who scored greater than, the same thing. But the other one was just asking for the probability, the chance of getting people who scored either less than or greater than or between. And now, remember, anytime we talk about this, you should be thinking about the one-tailed, two-tailed. Okay, so in this case, since we are looking for the actual number of students, we will start with the old steps. I mean, we are going to follow the same steps. But after getting the normal answer as we used to get for the first application, we will move further to do one thing more. So let's start. The first thing is, as usual, you write your problem in probability form. You write your problem in probability form. So we're asking for the number of students who obtain scores less than 12. The number of students who obtain scores less than 12. So in probability form, you have your P here, which is the probability, into brackets. X stand for the scores less than, and the question here, the question is asking for the scores less than 12. So it should be X less than 12. And this is a summary of the entire question. The probability form here is a summary of the entire question. The second step is transform the original probability form to a z-score form. And remember the formula for the z-score. Z-score, or Z equals X, the obtained score, minus the mean over the standard deviation. I said always you will use the number in the question. The number we want to know, either people have scored above or below, or if it is between, then you use the two numbers, but you work for them separately, okay? So that number in question always come first. So you write your 12 here. The 12 is the number in our question. And we're asking for the number of students who obtain scores less than 12. So 12 minus, what is our mean? Our mean is 16. And after getting your mean, now what is our standard deviation? We are fortunate to have the standard deviation in the question. We are not going to do any calculation on the standard deviation. Remember I said anytime you are given a variance, that's where you will square root it to get the standard deviation. But if you are lucky, you have straightforward the standard deviation, you have to just substitute it into the formula and start working. So the second step is, after getting this, you reduce the term further. By reducing the term further, what will be our answer? We are going to get 12 minus 16 will give us what? 12 minus 16 will give us negative 4. So we have negative 4 over 2, which will give us negative 2. Negative 2. And negative 2, the next thing is you draw the curve. You draw the curve. And in drawing the curve, since it is in the left direction, since it is less than means you have to move towards the left direction. So it's less than, and we know 1 will be here, negative 1 will be here, negative 2 will be here. And we are looking for scores. We are looking for the number of students who are likely to score less than 12, which after converting the 12 to z-score, we got negative 2. So, and on the normal curve with numbers, always have in mind that the numbers below the 0 are always lesser than 0. So the numbers below negative 2 are all less than or lesser than negative 2. So if you are looking for values which are less than 12, then that means after converting to the z-score, which we got to negative 2, we are going to shade the space before the negative 2. And after you go to the table, you go to the table, the standardized normal distribution table, and search for -2. But since, remember I said with our table we don't have -2, so you will still use the 2. And searching for 2, we are going to get the 2 under the title 0.00, since it is in one decimal place. So the 2 will be 0.4772. 0.4772. And since we are dealing with only one side of the curve, we are going to use the one side which is having the total 0.5. I've explained this severally. So what we have to do is, after getting our value from the table, which is 0.4772, we need to deduct from the total of the half of the curve, which is 0.5. And I said because the value from the table is in 4 decimal places, so we need to add 3 zeros to the total of the half of the curve. I mean the half of the curve, which is going to be 0.500, to help us ensure consistency in the two values, or with the two values. After deducting this from the half of the curve, you are going to get 0.0228. 0.0228. Anytime you are asked to find the number of students, not the probability nor the percentages. If you want the number of students, how many students, after computing the normal probability, you have to move further to multiply your final answer by the total number of students given in the question. And here, remember, we are talking about a class of 400 students. So your final answer should be multiplied by 400. And this will give us 9.12. This will give us 9.12. So let's take note of this. We shall use the convention that every fraction, no matter how small, becomes a whole number, since we are dealing with human beings. So anytime you are searching for human beings, the total number of human beings, and you get your answer in decimal, no matter what, you should convert it to a whole number. You have to increase it. You can see that the decimals are not decimals that in normal sense we can approximate. But because we are dealing with normal human beings, I mean the number after the 1 is not 5 or more than 5. It's 2. 2 is less than 5. Now in normal sense, we are supposed to maintain it as 9. But since we are dealing with human beings, what we are saying is that whatever decimal you get after the whole number should be approximated to the next whole number. So here, we approximate this answer to get 10. So the final answer becomes 10. You write this first and now convert it to 10. Therefore, approximately 10 students had scores less than 12. 10 students had scores less than 12. Okay, so we've ended the session on the application of the normal distribution curve. Now the session review. In this session, you have learned about 3 applications of the normal distribution and the normal curve. We've learned about how to find the probabilities using the normal curve, how to find the percentages using normal curves, and how to find the actual number of students. The next is the normal distribution and the normal curve can be used to compute probabilities. We are aware of that. We've learned how to do that. We can use it to determine percentages, and we can equally use it to obtain the actual number of students who have reached a certain performance level. Okay, so this is an assignment, our second assignment. I want you to do them and send them to my Telegram platform, just like you did for the first assignment. Thank you for listening. I hope you've understood it. If there's a problem anywhere, kindly call for clarification or for further explanation. Thank you. Bye-bye for now.